So next, problem 20 is another problem where we've got two triangles that look like they're sort of stuck together. So I'm going to go ahead and I'm going to draw a diagram of how we can, in our minds, separate these two triangles out. So we've got on the left, got a triangle A, C, and B. Let me zoom out just a bit so you can see what I'm writing down there. Okay, good. And on the right, got a triangle that's sort of A, C, and D. Okay, so even though this line and this line is the same, we can kind of think of them as two separate triangles. So we've got ABC on the left and ACD on the right. And let's go ahead and figure out whether these two triangles are congruent. We have congruent angles. Okay, we have a sign that those two angles are congruent because we've got a line. We've also got AB congruent to AD. Okay, and as usual, we are going to use reflexive property to say that AC is equal to itself. AC is equal to AC. So when we look at these two triangles, do we have one of the criteria for congruent triangles? Yes, we do. I hope you recognize that it's side angle side. Okay, side angle side with an included angle. This is an included angle because it is falling between the two sides that are marked. Okay, now let me show you some notation that we'll sometimes use or you'll sometimes see being used. On the same diagram, where the original diagram, we can do something like that. We can draw an X over the side that's equal to itself. That's like sort of drawing a line and then another line on the same line showing that it's equal to itself. So we could have separated it out in our minds like this, or we could have indicated like this. But either way, we have triangle ABC, and do you know how we would notate that? So A is opposite the side without the mark, and so is A here, so it would be A. B is opposite the mark of X, so is D, and C is opposite the single marked side on both of them. So it would be ABC is congruent to triangle ADC, and the reason is side angle side. So let's go on now to question 21. And we've got two triangles again. Again, our first one is called ABC. And our second one, if it is congruent, would be something like ECD, right? It's the triangle on the bottom. So the question is, do we have enough information? Can we call these two triangles congruent? Well, we're given by the diagram that B is congruent to E. Okay, and we're given that line segment AB is congruent to line segment ED. Again, they each have this little mark on the side. And we know that vertical angles are congruent. Okay, and we know that 1 and 2 are vertical angles, so we could say angle 1 is congruent to angle 2. So I'll just put double markings there. Well, so far, what corresponding parts do we have? We've got an angle, we've got another angle, and then we've got a side. So we've got two angles and a side. Well, we don't have a congruence criterion for two angles and a side, but this problem will help us develop one. Okay, because I want to point out that we're going to use the theorem that we have from the other side of the paper to show now that angle A is congruent to angle D. So we can say A is congruent to D. Well, how can we say that? Well, we can say it because, remember, if we have two corresponding angles that are congruent between two triangles, the third angle must be congruent as well, because the three angles add up to 180 degrees. So therefore, angle A is congruent to angle D. And now do we have a congruence criteria? Take a look. Well, we have angle, 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 but that's not a congruence criteria. But we have a side. We have angle, side, angle. Okay, so here on the top triangle, we've got angle, side, angle, and the corresponding elements on the bottom triangle are angle, side, angle. So angle A corresponds with angle D, side AB with side ED, and angle B with angle E. So we have angle, side, angle. So our reason is angle, side, angle. And I'm going to put angle, angle, side in parentheses, because as you remember, we started out with angle, angle, side, and what we've really done in this little proof here that we didn't kind of write out, but we reasoned out, is that angle, angle, side is going to always be equivalent to angle, sine, angle, because that third angle, which ends up on the right side of the side, is always going to be congruent if the other two angles are. So we kind of invented a new, well, we didn't invent it, it's been around for a long time, but we kind of discovered for ourselves another congruence criterion, which is angle, angle, side. So we can add that to our collection, because angle, angle, side, and angle, side, angle are equivalent. So we've got a triangle ABC is going to be congruent to, so let's take a look, angle A, it corresponds to angle D, angle B corresponds to E, and C corresponds to itself, to C. Okay, so triangle ABC is congruent to triangle DEC is the correct answer here.